Okay. So, is recording my voice? Hopefully it is. Okay. Hopefully it's recording now. I think so. All right. Yeah, there we go. All right, great. All right. So someone can read 5-1. So Peter, yeah, go ahead. Yeah, I was gonna call on you anyway. Go for it. Yeah. Okay. Can a tangent ratio be used to solve this? The answer is no. And why not? You don't know opposite? Correct. You don't know delta y, which is the opposite, or delta x, which is the adjacent. You don't know that. So, okay. So what are we going to do? We're going to learn some new stuff here today. So 5-2. In order to find out how high Juanisha climbed in problem 5-1, you need to know more about the relation between the ratios of the sides of a right triangle and the slope angle. So we have some strategies we can use here. So for example, use two different strategies to find delta y for the slope triangle shown in the diagram at the right. Okay. I'm going to label these as A and B. Okay. You guys should be pretty comfortable solving for these letters. So what famous relationship or theorem would I use to solve for each of these letters? What was that? No, theorem. A squared plus b squared equals Python. Good. Yep, good. You got it. A squared plus 1 squared equals 2 squared. A squared equals 3, so A is root 3, correct. And I suspect we're going to have something kind of similar because we do have similar triangles, of course. And how do I know I have similar triangles? Because we see that we have 6-2 and 3-1. And I suspect the bases are probably, or the horizontal legs are probably parallel. So I have corresponding angles equal to each other. So I'm pretty sure these are going to both be 60 degrees. That's 60. And of course, the other one was labeled as 60. But we'll work out Pythagorean theorem anyway. So if I work out anyway, I should get 3 squared plus b squared equals 6 squared. You can also use ratios from the previous triangle, but we'll just do Pythagorean theorem again. It's a little bit larger numbers, right? B squared equals what? My apologies. And it, b squared is 27. There we go. My apologies. I know it seemed off. When you square root that, this is why I'm so bent on you guys learning how to simplify radicals more easily. We gotta work on that. What factor of 27 is a perfect square? 9, yeah. Good. So you get 9 times 3. And of course, it's 3 root 3. So delta y, it looks like we have two different values actually for delta y. But if we think about it in terms of a ratio, find the ratio of delta x or hypotenuse for each triangle. So for the small, so right now my delta y's are we'll just stick with these for now. We won't make a conclusion yet. We got two different answers. We got √3 and 3√3. Okay, so we'll say √3, 3√3. We'll just go with that. Then for part B, the small triangle, you do delta x over the hypotenuse, 1/2. For the big triangle, what do you get? 3/6, right? What does that reduce to? So why must these be the same? Similar triangles. That's why. So what this tells me is that delta y is probably √3. I did have 3√3, or the slope. Sorry, the slope is going to be √3.
Why not?
Because you either have √3 over 1 or 3√3 over 3. If I do 3√3 over 3, the 3's will cancel, right?
How do you like so?
Oh, because for this one here, what was a delta x for that one?
Oh, okay.
So it's just a ratio. That's all I'm doing.
Okay.
It's all proportional. So I know the slope. The slope's gonna be √3 for both triangles. Okay, go ahead.
How do you know what like triangle X means? Like what number that is?
Oh, delta x?
Yeah.
It's the horizontal leg of whatever triangle you're working on. The leg that's flat. So whichever one you're looking at. Because remember, x is horizontal. It's always horizontal. So if I look at this one, find BC and AC. So if I use the same ratio, that's going to be 3.5. And that's going to be 3.5 √3. I didn't have to do any work for this. How come I didn't have to do any work here? What relation did I notice between these two sides? They were always 2 to 1, right? Or 2 to 1, whenever that was 60 degrees. That's what I noticed. So what's 1/2 of 7?
3.5.
And then this side is always √3 times that, right? You notice that that's √3, that's 3√3. So if that's 3.5, this has to be 3.5 √3. So all I'm doing is maintaining the ratios that I established earlier on. And why can I do that? Because do I have the same angle? I do. And we know that when you have this angle always sets these in this consistent ratio. We know that because it's tangent. We learned that already. Remember, what does tangent represent? Tangent is simply the ratio of this side over that side. That's all it ever is. And it doesn't matter whatever, whether you make the angle, the triangle bigger or smaller, as long as the angles are, the corresponding angles are the same, the ratios are maintained because of similar triangles, right? The ratios don't change as long as you maintain the same angles, right? It's always gonna be the same. So questions on that? We're good? Okay, cool. Right. Okay, so let's move on. Let's go to the next page and maybe have you guys do some practice. So actually, I still got to talk to you guys about stuff. Then I'll have you do some practice on down below. Yeah, Reagan, go ahead. Yeah, sure, go ahead. Yeah, fire away. Actually, I'll do it. Let me leave right here so I don't forget. Yes, you will today. And actually, I have retakes from before as well. So yes, I'll pass back everything and I'll leave right here. So yeah. Sure, yeah, of course. Okay, so we're gonna talk about some new trig functions or ratios. Actually, Reagan, can you read the beginning part where it says new trig? Just read up to part A. So yeah, come on.
Yeah, sure.
New trig ratios. In problem 5.2, use the ratio that includes the hypotenuse of ABC. There are several ratios that you might have used. One of those ratios is known as the sine ratio. For the triangle shown, another ratio comparing the length of the side adjacent. The angle to the length of the hypotenuse is called the
Cosine.
cosine.
Yep.
Yeah.
Yep.
For the triangle shown.
So yeah, so cosine is kind of like it's actually called a complement. We talked about complementary angles a while ago, but we'll have to come back to that later. Complementary angles add up to 90. And of course, these two angles add up to 90. So cosine stands for the complement. It complements the sine function. What you're doing is for sine, you do opposite over hypotenuse. Cosine, you do adjacent over hypotenuse. There's actually a way to help you remember this, and I'm sure it's probably, yeah, I guess we're doing geo honors in the other room. Okay, there's a way to help you remember this. There's a mnemonic you can use. There are also some other ways to remember this, but this is the most common. It's called SO, Ha, TOA. Okay, you guys heard of it? I don't know. So sine is opposite of hypotenuse. Cosine, adjacent of hypotenuse. Tangent, opposite of adjacent. So, so it's kind of phonetic in a way. So that helps you remember what goes with what. So sine is a ratio of sides, cosine is a ratio of sides, tangent is a ratio of sides. Depends on what you're dealing with. So for example, I have like root 3 and 2, then I'm going to use sine. If I'm doing with 1 and 2, I'm going to do with cosine, right? And again, hypotenuse is on the bottom, the opposite of adjacent is up top, depending on which one you have. So these are more trig ratios we can use to help us solve for missing sides, depending on what you're given. So depending on what you're given, use the proper trig function. And these are all in the calculator, by the way. There's other ways to remember this. I can't remember them, but if you have any cool ways of like PEMDAS, please excuse my dear Aunt Sally, something like that, just let me know. Okay, so that's what's happening here. This is new stuff. We're going to apply it. So part A, William, can you read what part A is asking?
Sine ratio is for everything. Okay, the sine and cosines on your calculator. Use them to find the sine and cosine of 60. Does your calculator have the correct ratio?
Okay, cool. So what we're going to do right now, I'll just kind of, if you want to follow along, if you have a calculator, great. But I'll do it on my little calculator here. So I'm going to type in sine 60, hit enter, and I'll show you the result in a moment. Cosine 60, hit enter. So you get those numbers there. So what's happening? So say, for example, this were, actually, let me draw a little more accurately.
What are you trying to even like? Are you trying to find the other angle?
We're trying to find the ratios. So what this tells me, great question. Yeah, what are we actually doing? Right. But what are we doing? What this tells me is that when you do sine 60, the opposite over the hypotenuse equals 0.866 and a bunch of random decimals. This also tells me that the adjacent over the hypotenuse is 1/2. Because 0.5 is 1/2. We should know that, right? So what I could do is I could say this side here is 1 and the side here is 2. Right? That makes sense. Oh, I'm sorry. I meant to do the other way around. My apologies. My apologies. Sorry. I meant to do that. Adjacent's 1, hypotenuse is 2. So if that's true, and I'll call this y, how would I solve for y? We should know this already, right? What does y equal? Root 3, exactly, right? And it makes sense, because if I were to do root 3 over 2, so if I had second square root of 3, move to the right, divided by 2, you actually get the same thing as sine 60. So that's what this is. These are just ratios of sides, depending on the angle that you're given. You'd use it to find missing sides, but like if you have like if you want to find like how tall a building is and you know how far you're standing from it, you know the angle, or you want to know like the distance between like if you have like a like say some sort of like fish line or string from the top building down to the ground, you want to find how long it is, but you only have like an angle in the side. Sure. Or if you know the hypotenuse, you're trying to. Sure. Yes. Exactly. Yes. Right. But what if we don't have everything? We're gonna find out. Let's do it right now. So go. Yeah, we're not ready for that this week. We'll do it next week. Yeah. Or we could do like a high of one of the redwood trees. You want to do that? That'd be cool. Not today, next week. We're gonna actually take a little filter around campus and measure stuff. Yes.
Doing that calculator, like, what is
That's just to show you that these trig functions, sine, cosine, are the ratio sides. They represent the ratio sides of a right triangle.
But 2 and 1.
No, what I did was when I did cosine, let me back up a little bit here. When I did cosine, I got 0.5. Cosine is defined as adjacent to the hypotenuse. That's how it's defined. The adjacent side would then be 1 and the hypotenuse would be 2. You guys see that? When I punch this in the calculator, what did it spit out? 0.5. Cosine?
No, like, how do you know if the hypotenuse is 2 and the leg is 1?
Oh, well, think about it. That's how, well, first of all, you have to accept the definition of cosine. That's the first thing you have to do. The definition of cosine is adjacent. You have to just accept that. That's adjacent to hypotenuse. So now that we've accepted that, adjacent goes with 1, hypotenuse goes with 2. It's just a definition we have to accept. That's all. Yeah.
Why wouldn't it be like 2 of them?
You can, totally, 100%. If we made 2/4, then if I do Pythagorean theorem, actually, I'm glad you said that. I'm very glad you said that. That's a great observation. Because this now proves why these are all about ratios. Okay. How would I solve for y now? And you should get 12, I think. And then y equals √12. You guys now simplify that? That's why I care about simplifying now. 2√3, perfect. Thank you, Cam.
So what do you need to use this? Innings?
Correct. Yes, we do. Correct. Well, no. You do need sides also. I mean, sorry, I didn't understand your question. You need sides and angles. You need both. Just be patient. Just wait, because we'll do some examples. Just wait right now, because I think you're overthinking it right now. If you look at the ratio between this and this, 2√3 divided by 4, opposite of hypotenuse. What if I did 2√3? I have to type this in. 2√3 divided by 4. Correct, right. But this just helps us to understand that all these are proportional. Let's go back to the notes. Let's do an example, because I think that will help things click for you guys. So when we worked it out, sine 60 was 0.866, which really was √3/2. And cosine 60 was 0.5, which is really just 1/2. I mean, that's pretty obvious. 0.5 is 1/2. You guys should know that. That's not obvious. But how did I figure that out? By assuming the sides were 1 and 2 and using Pythagorean theorem. That's how I knew that. I had to make an assumption. But what Peter said, when I did 2 and 4, fine. I did 2 and 4, that's still 1/2. I still got the same ratio for sine 60. But I did opposite of hypotenuse.
When do you use sine and when do you use split?
Now we're gonna do it. We'll talk about it right now. So let's look at part B. Connor, go ahead.
Sine is the opposite side in person.
Adjacent, right? That's why I have a mnemonic to help us remember. I'll actually write it again on the side here. And Kira, go ahead. Other way around. So let's look at part B. Okay. So now, Faith, to answer your question, let's take a look at this. So now, to all these problems, you need an angle on the side. If you have just one angle, then forget about it. Right?
Yeah.
You can't do anything. If you have a side, forget about it. You can't do anything, right? You need a side and an angle. Yeah, I have an angle. Cool. Now, I have the hypotenuse. Cool. And what do I want to find? This side. The problem with tangent, here's the problem with tangent. I don't know the opposite. I don't know the adjacent. There's 2 unknowns. Now it's clicking good. That's what I'm saying, be patient. So here, I want the opposite. And I know the hypotenuse. Which one uses O and H? Which one uses O and H? That's why you're going to sine. Exactly. So here's now hopefully I think this will really tie it all together. Determine which side you want and which side you know. then use the proper trig function. That is the whole essence of it. I want the opposite. I know the hypotenuse. I know. So I want to connect. I want to relate. There we go. I want to relate O and H. Which of these letters relates O and H? The S, the C, or the T? Which one uses O and H? There we go. Good. So you're gonna say sine of 23 degrees. And it's the first time you guys seeing this. And don't mind me if I do like sometimes feel like, wait, how come you guys not getting this? I teach pre-cal BC honors where they've done this for like 2 years. So don't take any offense if I like, well, how come this is not clicking? I'm trying to come at this at a pun intended at a different angle. You guys get that? It's a good one, right? Okay. All right. Yeah, see, I crack myself up sometimes. It's a dad joke. Sorry. So sine 23 degrees equals A over 15. That was a good one. Let's write that down. All right. So yeah, sine 23 degrees equals A over 15. Before we solve it, let's look at this one here. Okay, I want B, and I know 8, of course. This side here is right next to 37. It's not opposite, clearly. Opposite would be over here. This is a hypotenuse, because opposite the right angle. So adjacent, hypotenuse. I want to relate adjacent hypotenuse. I want to relate A and H. Or A and H. Cosine, correct. Correct. I want to cosine this case. So you have to really take the situation for what it is and act accordingly. That's what you want to do. Colette, go ahead.
So for like opposite, like an adjacent where it's like under the horizontal line you have thing and the vertical line,
Yes.
it's tan. But then for like the vertical and like the hypotenuse it's sin, and cos is 8.
Yes, correct.
Oh, okay.
But that's all assuming you're using a base angle, an angle that's on the base. What if I using that angle? That's all reversed. We won't go there today. We'll keep it simple for you guys. But ultimately, we're gonna have to do that. I'll go. Yeah, of course, Wait, go ahead.
So then do I just plug like that into my calculator? and
Yes,
then I'll-
correct. Yes, you just let the calculator do the dirty work. So A would equal 15 times sine 23 degrees. We'll see what that tells us. It'll be an approximation. B will equal 8 times cosine 37 degrees. We'll see what that tells us. And let me get my calculator here. .86. And 6.39. Yeah. And by the way, side A should not be more than 15. Side B should not be more than 8. Right? Because the legs are never bigger than the hypotenuse. If you get something funky, like you get a really long side, or you get like a negative number, or something that just seems super tiny, then you know you've made a mistake with the setup, or maybe the calculator's in the wrong mode, maybe it's not in degree mode, maybe it's in radian mode. I don't know. There's a lot of ways you can mess these up, so we have to be careful, right? And I'll understand physically, does that physically make sense? Also, another thing too, let's say I want to find the horizontal leg for the first triangle. 23 is obviously smaller than this angle here. This angle will be, I think, 6, 7. So I expect this side to be more than that side. If it's not, that doesn't make sense either. Always make sure the smaller angle, shorter side, bigger angle, bigger side, right? Always make sure you, or larger angle, longer side. Okay. Hopefully, trust me, that this will click really fast. Well, it's a little shaky at first. Once you get the hang of it, it's pretty smooth. Okay, questions? Good. Okay, good. I'm actually not gonna be here tomorrow, so we'll see how E-period does. It's my son's birthday tomorrow. So yeah, he'll be 9.
What do you guys do?
Whatever you want to. I think you might want to do like miniature golf maybe, or go out to dinner. So yeah. I don't know. We'll figure it out. So
Do you live near?
Or
Or is he skipping?
no, he'll have school, but I mean I'm just taking a day off. I have other stuff I have to do too, but I just want to just be more available. No, just we can keep it simple. So yeah. Yeah, they have parties all the time. So the middle one had a party last weekend. So yeah.
For this one?
Hmm?
We don't have math.
No, we don't. But we'll see how the other class does, because this is like a tricky topic.
They have,
Yeah, but I'll have a video for them, so. Yes, Connor, go ahead.
This one, since both lines are out there, can we just do solid both?
Yeah, exactly, correct. So what we're gonna do for this one, was another question? Yes, go ahead, yeah. Sure, go. Both go, all right. All right, okay. So yes, what Connor was saying, cosine of 17.5 degrees equals delta x over 100. Or you could do this. I don't really care which one you go with first. It doesn't matter to me. It's up to you. Here's the thing though, once you solve for one of them, you could then do Pythagorean theorem to get the other. Or you could do trig again if you want. You could do both of these if you want simultaneously. Let's do both of those. Sorry, was that? You could, yes.
Yeah.
But we didn't know it before. Now you know. Now you're aware, right? Now you have more knowledge. Correct. Let's do delta x first. So delta x will equal 100 times cosine 17.5 degrees. So a little bit of algebra going on here. Delta x is approximately, what's that going to be? Cos 17.5 times 100. We'll go to 2 decimal places. We'll say it's 95.37. So it means you walk that much horizontally. And that's in feet? Yeah. So delta x squared plus delta y squared and then you can solve for delta y, or just do trig again. So it's up to you. To get delta y, once you get delta x, get delta y, you do this if you want, or you do this. I don't really care. Fully up to you. It's your choice. But either way will work. Either way will be consistent, just so you know. So for example, if I solve for delta y, I'll just kind of skip some steps. I'll do 100 squared my calculator, minus the other guy squared my calculator, root the whole thing. You should get 30.07. Or if I did this, delta y equals 100 times sine of 17.5 degrees. Because all the trig ratios assume right triangles. If I do that, sin 17.5, you get the same exact thing. So it's your choice, whichever one you want to do. I don't really care. But you can't do Pythagorean theorem until you've done at least sine or cosine once. You have to do sine or cosine at least once, and then do Pythagorean theorem afterwards, or just do sine cosine both times. Again, I don't care. It's up to you.
You can use the T one. Yeah.
Actually, you could then tangent also. Once we solve for delta x, I could then tangent. Actually, you're right. If you want to, once I knew what delta x was, I could then tangent. Yeah.
Angle and all.
Yeah, I could have tan 17.5 equals delta y over my new delta x. Sure. That's fine too. So you have options, right? The law of options you can use. And again, either way is fine for me. All right, the home stretch here. Okay, so now you guys understand what's happening. Go and try these on your own or next to your elbow partner, whatever you want to do. Remember, opposites opposite the angle that's given to you. Adjacent is the leg next to an angle given to you. And hypotenuse is obviously opposite the right angle. I'll set these up for you just so you at least know the setups. So like for part A, I'm going to do cosine 17 degrees equals 3 over x. For B, I'm going to do sine.
What's the eight? Yeah.
Adjacent or hypotenuse. Well, I need to fix that.
Yes, and cross it, and then. Oh my god, and then some times three. It's like, yeah, and it's like. I know what it is. 0.9.
Because adjacent's 3. X is hypotenuse.
I know.
3 is adjacent. That's why.
Wait, you did.
Yeah, I'll come by and help you guys out. Let me finish writing this up. I'll come help you guys out, okay? Yep.
Like 9.3. But that's the same thing.
Oh, got
No, I'm saying like, okay, so think of this as like, so it's like 3 over x. Like 4, 9, 5, 6. So, and we'll say this over 1, so we do this and this. And you make like your equal ratio, so. I think that's like. Okay, so 3 divided by. I usually put like answer. Put it this second.
Okay, so copy those down. Those are all the setups. Work them out.
So that.
See how you guys do. I'll show you the answer in a moment.
3.14.
No, so this is times 25 equals.
Raise my screen.
Mr. E.
I need to figure out the homework too. Yes, click that.
Wait, never mind.
Okay. No worries. All right. Yeah, go ahead. Needs help? Sure. It's fine.
F equals 3.8.
It's sick, right? So it's 9.
How you doing?
No, the answers.
I have them somewhere else. I'm just trying out the homework for you guys.
Wait, I have 3.8. For which one? I haven't, no, that's like my, thin.
So you guys have finally gonna have like.
Always opposite over adjacent from. So much,
Yeah.
it's always opposite over adjacent, all of these, for all of these is always opposite over adjacent.
For tangent. Yeah.
For
Also, at the bottom is this response. So yes, you have to use the proper one, but when you're.
Wait, is it?
I-
opposite over adjacent? Okay.
That doesn't seem right.
Which is the mnemonic of.
I divide some.
All you had to do is.
I thought it was like 9x, so it's like this kind of this.
It's actually.
But like. Let me just ask this, you got it, you might tell me.
Yeah. Yeah, it's.
Let's gonna move on.
Wait, am I taking it wrong? Cause don't you just multiply that?
I'm just like moving it because you want to be in the base corner, you know what I'm saying, so I'm flipping the triangle. Like, so this is 5, and this is x, and 45. It's like, the only way these formulas work is if it's in the base.
But did you get 1.8?
I did. I did. Because wait, that's what the base equals, so go to the triangle last one.
No, you're not.
The opposite over adjacent. It's like, no, because you use like this, because
Got three.
it's like.
Wait, what are like the
Okay,
things?
you're right back.
What are like
Not just a bomb.
like sine is opposite over hypotenuse?
Like, sorry, you were right.
And then
It's like opposite over adjacent, so this is the opposite.
what's when the tan is opposite over adjacent?
I think
Or sine?
they're. what sign is, this is what like I thought it was. If it's tan, then it's like this, that's like how the angles are. And if it's like, kind of like, you know what I'm saying? Like that's where the thing has to be, like, there's the side of the pause.
For every reason, but.
Good, I looked you guys honest, you guys really didn't care about work. I'm making copies of homework so you guys have it. Let me show you guys the answers and then I'll give you guys the homework. Moment.
Mr. Elmosson, funnily enough, I think the answer to A is 3.14.
Is it really? Or any of these have 6, 7?
So funny. Oh, no.
No.
So.
Yeah, it's just these finding interest in these things. All right. Let me show you the answer. So by the way, your notes have the answer keys now. So you should always be checking your notes afterwards. I did make this yesterday because it wasn't a previous one, so I could be wrong. Mr. What? Okay.
Right, that was fine.
Oh, cool. All right.
It's okay, he was a great, so like.
Oh, thanks. All right, that's a compliment. All
Kids-
right.
That's like kids around your age and he makes dad jokes, so.
Okay.
it's like-
I don't mean it's just to come out. So go ahead. Yeah.
Back.
Yeah.
Okay. But you said it has to be a base angle for you to be like the tan thing, but. what
Well,
you
no,
have-
not necessarily. No, I just said we've been working at base angles, but when the base angle change, when you're not using a base angle, everything switches. Meaning that now you're doing like horizontal. Whatever.
the inverted.
We have to inverse for any of these, because every time we're given an angle, so we have to inverse for any of these.
It's when the variables on the bottom then you do.
No, that's when you solve for an angle. You do it inverse. We're not solving for an angle, sir. Just sides. Okay, guys, so cosine 17, 3 over x, sine 25, x over 9. Tan 45, that's pretty easy. Tan 62, 5 over x. Sine 34, 13 over x. Cosine 20, x over 10. Remember, x can't be more than 10. X, well, I guess whatever it is, that's what it is. X is gonna be a little less than 5, because 5 is obviously bigger, obviously a bigger angle. Those are identical. We have the identical angles. Obviously, that's less than 9, and that's more than 30. So those are all the answers. That completes the lesson for today. I think that's a lot to handle one day. Let me go pick up the homeworks. Homeworks I produced are 5 problems. They're in Schoology right now. The list 5 questions.
Just 5.
Just 5, yeah. And I'll pick up the objects right now. You guys have it? Let me go get it right now.
What is he doing for? Like, how is he getting from that?
Like, okay, basically, if you have like the two flat sides that mark the hypotenuses, you use tan. If you have one hypotenuse and one vertical side is thin, and you always do opposite over adjacent for your like angles, like for your ratio, and then you always like cross multiply, like, you know, to get like, okay, like 4, 2, 3 equals like x over 9, 7, 9. In that case, I was definitely wrong. But like, so you do this right.
So those are all the answers. If you guys want to get to our homework, you may. We still got like 9 minutes.
One of you can.
Oh, let's do that. Some favorite measure.
Happy with the
Wait, how many problems did he say?
Relationship with these.
Yeah.
So.
Oh, we must have tests too.
That was that was 90 with 180.
Well, you could do 6x plus 8, plus 2x plus 2 equals 9.
Oh, that's true. So, okay. So, 8x
This is
Equals the. So, that's what So then six, so 60 plus 8.
This is those that we already talked about, that kind of mentioned, but.
You got 22 and 60.
Why?
Yeah, well, can you describe your relationship?
I don't even want this. Yeah, we can. Tutor.
There.
Because you need for your retake.
They're- They material.
You were during. Maybe next week sometime with chats.
Wait,
Is this what we?
like the. And like, okay, what are they? They're like the same size maturing, so they're. Same. For trail? Wait, how can you describe the relationship of?
Wait, are we keeping these?
Yeah.
That would be.
Yeah, good.
Oh, they have to 90.
That's all you have to say.
Yep. Yep.
And then we have sideline for each child. Yeah. So. We should. No, you don't have the. Actually, we have to do this. So, and. Oh, no. Side, opposite. Equals opposite, so. We don't know what the opposite is.
I just look for whatever has that. I did not see that. It's like the side thing. Yeah, like 5 minutes.
What's the opposite then?
It's change opposite and 82 to change.
Is it a motion?
So,
Do you have them?
So then tan eight times.
yeah, let me do it right now.
Oh, it's 1.4.
So be sure to find
Hard to know.
This.
because it's opposite over Jason, if Jason.